Today is Friday, April 24th, 2026. Welcome to This Week in Natural Refrigerants News, where we recap the top stories on naturalrefrigerants.com. This podcast is generated and read by artificial intelligence and may contain errors. We're your hosts, AT and MO, and the articles for today's podcast were organized by naturalrefrigerants.com's managing editor and written by its writers. You can find links to each article in the show notes.
Yeah, we've got a lot of really interesting ground to cover today.
We really do. We're looking at everything from the new atmosphere report on European CO2 sites to, well, some pretty intense legislative battles happening in New York.
Right, and then we're getting into some fascinating hardware applications too, like data centers and industrial steam generation.
Exactly. So let's just jump right into that atmosphere report. I mean, European transcritical CO2 sites hit 111,650 in 2025.
Yeah, it's a huge milestone.
Yeah.
But the really telling part is when you look at the 106,000 retail sites within that total.
Right, because the larger racks grew by like 15%, but condensing units actually surged by 24%.
Exactly, which is a massive shift.
So CO2 is finally conquering those smaller footprints. But why is this specific acceleration happening right now?
Well, it's really the intersection of manufacturing scale and technical optimization. Sizing down transcritical CO2 used to carry this massive cost premium.
Right, for like a small convenience store, it just didn't make sense.
Exactly, but component manufacturers are just aggressively optimizing their designs for those lower capacities now.
So the financial barrier is finally collapsing.
Yeah, especially with strict European regulations basically pushing out legacy refrigerants, the market had to adapt.
Speaking of regulations, though, it's not going so smoothly everywhere. I mean, look at the U.S.
Yeah, New York is a completely different story right now.
It really is. There are two bills in the state legislature, S235A3661 and S9066A9596, and they're aiming to roll back the NYDEC's Part 494 rules.
Right. They want to align strictly with the federal EPA AIM Act instead.
Exactly. And, we're just laying out the facts here. Trade groups like AHRI and Hardy are arguing that the state rules will financially ruin end users with high replacement costs.
While the NYDC and groups like NRDC counter that state-level natural refrigerant rules actually save money in the long run.
So what is the actual technical gap here? I know New York uses a GWP20 limit of 10.
Yeah, that 20-year window is key. It aggressively measures short-term climate impact, which, practically speaking, restricts end users to natural refrigerants starting in 2034.
But the federal AIM Act uses GWP 100, right? With a limit of 150.
Right. And that 100-year window kind of dilutes those short-term numbers, so it leaves the door wide open for HFO blends.
Even with the ongoing PFAS concerns.
Exactly. So rolling back to the federal standard simply extends the runway for those synthetics.
Interesting. Well, component suppliers are definitely reading these exact policy tea leaves.
Really?
Like Sanwa.
Oh, definitely. They're moving fast.
Yeah, Federico Bisco, their technical director for EMEA, gave a really insightful interview. Sanwa is explicitly targeting that cost gap we just mentioned in R744 condensing units.
Right, and they're launching their DBF series, EEV, for R290. They see where the market is going.
Which is why 80% of their EU business is now natural refrigerants.
Yeah, they aren't waiting around to see what happens. They're actively engineering the cost premium out of the hardware.
But here's the curveball. Bisco noted that in the Middle East, their natural refrigerant adoption is still sub 40%. Why such a stark regional divide?
Well, it comes down to regulatory sequencing. The Middle East just hasn't had that same regulatory leapfrog as Europe.
So they're transitioning differently.
Yeah, they're mostly moving from HFCs to low GWP alternatives, first heavily favoring R290 for plug-ins, rather than jumping straight to CO2.
Plus, even though ejector technology has solved the high ambient temperature problem for CO2 technically?
Right. The technology absolutely works. But regional market confidence is still just catching up to the tech.
That makes sense. Let's pivot from components to massive high-demand applications, data centers.
The Finigi project is fascinating.
It is. They're deploying isobutane and propane heat pump chillers to cool servers. They take 30 degrees Celsius waste heat and lift it to 80 to 95 degrees for district heating.
Yeah, using the HCI 3000 units, which are these 500 kilowatt modular systems.
Right. I look at it like Lego blocks, but why go modular? Why not just drop a massive 30 megawatt ammonia plant into a colocation center?
Well, a co-location center almost never opens its doors at 100% server capacity.
Oh, right. They scale up over time.
Exactly. If you install a massive 30-megawatt ammonia plant and run at a fraction of its load, it is a thermodynamic and financial nightmare.
So Finagi's modular approach lets you scale exactly with your IT load.
Right. You track the heat generation precisely, paying only for the cooling you actually need today.
That is brilliant. And speaking of isobutane, it's stepping up to even heavier lifting now.
Yeah, Turbodin's new installation.
Right, at Delfort's Tervakuski paper mill in Finland, they launched the world's largest steam-producing isobutane heat pump.
It's basically a masterclass in industrial decarbonization. They paired the heat pump with a mechanical vapor recompression unit and MVR.
Generating 12 megawatts of thermal energy, but the MVR acts like a turbocharger, right?
Yeah, exactly. The heat pump provides the baseline heat, and the MVR physically compresses the low-pressure steam to spike its temperature all the way up to that 150 to 180 degrees Celsius mark.
Completely replacing a fossil boiler and cutting 19,000 metric tons of CO2.
It really changes what's possible for heavy industry.
It really does. It leaves you wondering, if a paper mill in Finland can generate heavy industrial steam just by recycling its own waste heat, what kind of thermal potential is your local manufacturing plant just venting into the sky right now?
That is a great question to think about.
This is AT&MO, and this has been the Week in Natural Refrigerant News.